Hello everyone, and welcome to Jam Academy. In this example, we have a box of mass m being pulled up an inclined plane by a force of constant magnitude F at a constant speed. Now, we are required to calculate the rate at which the force F is doing work on the box, and the rate at which gravity is doing work on the box. The very first thing that we have to do in this problem is to start first by doing the free body diagram. We have the weight of the box acts vertically downwards. So this is the weight mg. The normal force acts perpendicular to the plane of the box. This is the normal force. And lastly, the friction force, which is kinetic friction in this case, acts in the opposite direction to the movement of the box. Now, I'm going to do this. I'm going to orient my coordinate system to lie along the plane. Now, this will greatly simplify the problem. So, what you need to note is that this angle right here is theta. And if that angle is theta, that means that we can resolve the weight into two components. You have the component, this will be mg cosine theta. You have this component along the plane. This will be mg, the sine of theta. Remember that the definition of the rate of doing work, or average power P is defined as the work done divided by the time it takes to do the work, or P is simply defined as the force multiplied by V. We can use either of the two equations, but in this case, I'm going to go with the second. So the first thing is we need to calculate the work done by F. So the question is, what is F? Because the system is moving with a constant speed, it means that the sum of forces acting on the block or on the box is 0. Now, in other words, the sum of forces along the x direction, which is equal to F minus mg sine theta minus f of k, this is equal to 0. Now, similarly, the sum of forces along the y direction will be equal to n minus mg cosine theta. All of this will be equal to 0. What can we gain from this? You can see that n is equal to mg, the cosine of theta. This gives us the magnitude of the normal force acting on the block. So by definition, f of k is just going to be equal to mu kn, which is equal to mu k mg cosine theta. That gives us the magnitude of the kinetic friction acting between the blocks and the inclined plane. Now, this would imply that F will be equal to mg sine theta plus mu k mg cosine theta. This is the magnitude of the force F acting on the box. Now the question is, we need to calculate the rate at which this force F is doing work. So P is equal to F multiplied by V, which will be equal to mg, which will imply that P is equal to mgv bracket sine theta plus mu cosine theta. This represents the rate at which the force F is doing work on the box. This is really beautiful. Now, fellas, the next question is to calculate the rate at which gravity is doing work on the block. The rate at which gravity is doing work on the block. Bear with me that the rate at which a force does work is equal to that force, the magnitude, the component of that force parallel to the direction of motion, multiplied by v. It's important you keep this in mind. So this means that the rate at which gravity does work will be equal to mg sine theta, because this is the component of the force of gravity parallel to the direction of motion, all multiplied by v, which is just equal to mgv, the sine of theta, mgv sine theta. Thank you so much for your time. Please, if you have any questions so far, I would love for you to ask in the discussion forum below. In the discussion forum below. Now, keep in mind that to calculate whether it is the instantaneous power and to calculate the average power, we can use the expression P equal to F multiplied by V. But the restriction here is that the force, the F, represents the component of the force tangent to the path of motion. Let me say that again. Represents the component of the force tangent to the path of motion. It represents the component of the force tangent to the path of motion. In other words, it represents the component of the force parallel to the direction of motion. Parallel to the direction of motion. It is important you have this in mind.